Welcome to Miss Early Science class. Woo! Today we're going over the Unit 4 study guide. The test is next week. You should be ready. You were born ready. This can be found on my YouTube channel, and where else did we say? Weebly, DCSM, science6.weebly.com. This is due for you guys on the 22nd, which is next Monday when you don't have school, but I'm going to collect them the day of the test. So I expect them to be done by the end of the day today, but I'm not collecting them until the day of the test to make sure you don't have them in front of you. Okay? All right. So the first part of this unit was energy. What's potential energy? Emerson. Very good. This is stored energy. So it has the potential to make Miss Burley upset. Don't do this. Not today. Hi, welcome back for spring break. We'd like to give you a bunch of problems today. All right, so stored energy. This has potential to move, right? Which means it could move. And we specifically said that it's energy due to an object's position. What specific form of potential energy is it talking about when we say due to its position? Remember we had that do now question that talked about it? Somebody other than Emerson. We have 3 forms of potential energy. Emmanuel, if you don't have a study guide, you need to grab one from the front of the room, honey. We did this in class together. What kind of energy was it? What kind of potential energy? Or what kind of potential energy? When I talk about position. You can phone a friend. Yeah, gravitational. So let's start with that as our examples. We're going to talk about the 3 different kinds. I have gravitational, elastic, and what's the last one, Brennan? Kinetic is motion. Chemical. That's our favorite kind. All right. Chemical potential energy. Give me some examples. This is any type of what? Begins with an F. No. Begins with an F and ends with a U. Come on. Fuel! This is any type of fuel, chemical. Chemical is any type of fuel. So this is, yeah, firewood, gasoline. Somebody said sunlight, which is true. Sunlight begins as nuclear energy, but then gets transferred to chemical potential energy for plants. Electricity is a different kind of energy. Remember, it's the movement of an electrical current. And we said food. What would a match be? Would a match be like if something is on fire? Say if I had a match before I lit it, that would be what? But as soon as I lit it, very good. So you're absolutely right. Clap it up. That was very nice. So, all right, we're good. A match before I light it, but as soon as it lights, it's no longer chemical because it's now thermal and radiant. What is elastic potential energy? Somebody give me examples of that. Ethan. A spring, so this is anything that's stretched or compressed. Yep. My elastic pants, yeah. So a rubber band, a spring. Ariana, do you have any ideas for elastic that we didn't say?
Slingshot.
A slingshot, very good. And then gravitational, what's that word in gravitational that sounds familiar? Gravity, which we know gravity is a force that pulls things down. So a gravitational would be anything that has potential to fall, right? Anything that could fall, like your grade. Just kidding. We all know it's just gonna go up from here. Anything that could fall. Give me some examples. Anything that could possibly fall. Ariana, she on it.
A roller coaster on a hill.
Very good. At the top of the roller coaster. Brendan, did you have another one? You're a really good example right now. Brandon's in a good example. He's got his chair put back like this, and then he has the potential to fall, right? But can you think of anything else? And when it's in space, it's in the gravitational pull of the Earth. It's in our orbit. But if I throw something up in the air, like a basketball, for example, it's gonna come back down, right? So like shooting basketball, for example. Yeah, literally throwing anything except for a temperature. All right, how do we feel on potential? I feel like you guys have the potential to do really well on this test. At what point in this picture would there be the most potential energy and why? Ayana. Why? What? They all, okay, B has the potential to fall. Well, what kind of energy is B? What is it, Christian? Mechanical, right? It went from potential to kinetic. What about C? Does C have more energy, potential energy than A? Does D have more potential energy than A? Why not? Yeah, because A, I wish you would have raised your hand though. Because it is at the highest point. And at rest. Remember we said if there's more height, what happens? More or less GPE? More. Because there's more potential for gravity to push it back down. We moving on to kinetic. Kinetic is what? Energy due to motion. Energy due to an object's motion. Now, I noticed, and on my website, I put examples of things in motion, but I want you guys to remember thermal, electrical, light, sound, those are all motion. Vibrations, motion, right? Thermal energy, motion. So underneath, I want you guys to write like sound, thermal, light/radiant, electrical, because remember that's, what am I, so ELTS, and then mechanical is a combination of both potential and kinetic. But electrical is movement of electrical currents. Radiant is electromagnetic rays, the movement of those rays. Thermal is movement of air molecules. Sound is vibration. All of those involve movement. But do we have any other like real life examples of kinetic energy? Possibly, maybe. That's my favorite one. How did you know? Oh my gosh. Where? Where? Oh, up there? Yeah. That's the cross country team. Yeah, I did. Well, we do cross country here at the school. And then when I was in high school, I did cross country and I did track. I was a no, but I have run a marathon. Ariana,
Sliding down a slide.
sliding down a slide. Very good. Track is super fun though, because there's a lot of different activities you can do. You can do fast, like super fast running. You can do hurdles are fun. So I encourage you that when you guys get to high school to try it out, because there's in track there's something for everybody. Oh, that's high jump. That's high jump. And then give me one more. Raising your hand. Give me one more. Ethan, driving. So like, yeah, a moving car. Ojos. Bring it back. All right, but I said ojos, but like let's bring it back. We can talk about that when we finish. Do I need to introduce our class to you? What type of energy is increasing as I kick a ball up in the air? So as the ball is moving up in the air, what kind of energy is increasing? Gravitational potential, because I'm increasing height. This is for real test question. Yeah. I said you can have brain dump paper to draw. Because we have to get you guys used. I mean, I'm a very paper-based person, but we have to get you guys used to those, to being able to use the strategy of writing on a separate sheet of paper. Because all of your tests, for the most part, are gonna all be electronic. So what we're giving you the opportunity to do is to write on a separate sheet of paper to put your notes on, right? And to kind of annotate. And that way you get in the habit and don't have a mental breakdown like I did when I found out that my test was on a computer. It is, when I was a kid, we didn't have tests on computers like that. So it's good that you guys are getting practice like that because that's how all your tests are going to be, most likely moving forward. What type of energy is increasing when the ball is falling back down? So when it's going up in the air, it's increasing in height, so it's gaining gravitational potential. But when it's falling back down, what's it gaining? No, it's not gaining potential because it's falling. It's current. It's moving. Kinetic. Kinetic energy, because the ball is losing gravitational energy. Very good. I'm wondering where my people's at. So the ball is losing gravitational potential and gaining kinetic as it speeds up towards the ground. Not to put it in your head. All right, y'all better have this. And you know for a fact that whatever I have on this paper, there's a very specific reason I have what I have, right? So my suggestion would be to have what I have. Flip it. All right, so this is that food chain question that we did as a do now. Again, my suggestion is when you're studying to also take a look at the do nows because they are an awesome frame of reference. So how is energy transferred in living organisms? Meaning that not that they eat each other, right? We know that they eat each other, but is there more energy at the top or less? Less energy is available at the top. So every step of the food chain loses a little bit of energy. So there's less available at the top. The producers give their energy to the herbivores. The herbivores give their energy to the primary carnivores, or we call them secondary consumers, and so on. So every step of the food chain loses a little bit of energy because it takes energy to consume it. If I collect your study guides and it is missing stuff, I will not give you full credit. And then we already said that there's less energy available at the top. And think about like literally the space, right? The space at the top of the space in the pyramid indicates how much energy is available in that particular section. Yes. What do you have? That's perfect. That's fine. You might also want to write that there's the less energy and then the more energy. Yeah. Okay. So we're still focused on energy. Sound energy, just give me the definition here. Mazzy? Yep. Sound carries through vibrations. Wendy, make sure you have this, babe. Give me an example, Wendy. Yep. The sound energy. Give me an example of sound energy. If it's on your, talking, but if it's on your paper, like I've been asking you to have, then you should be able to share it with me. So can we put the binder on the floor, honey? So I can make sure that you have everything? Because I can see that your paper is not complete, which means that you should be writing when we're writing. So talking, give me another one, Brennan. Yeah, so yelling or echoing. We even said when you put your hand on, you can feel those vibrations. But yeah, like echolocation is all vibrations. A guitar. A stereo. Well, stereo is electrical to sound. Radio. Electrical. Give me the definition, Ariana.
The energy that electrical current carries.
Very good. Energy that electrical current carries. That means it has to be moving. Move your hand. All right, examples. Examples. Emerson. A power line. It literally is carrying electrical current. Christian. A plug. Carlos. Lightning. Very good. A fan, a toaster, solar panel. A phone. Very good. Ariana says a phone. Micah, do you have one? An idea of something electrical? You can send it in the chat if you want. Thermal. Thermal energy. Hey, Emmanuel, I need you to sit up. Same thing I just said to Wendy. Move the do now, please. And make sure you have what we have. Thank you. Bishop. Yeah, this is a form of energy that produces heat.
A fan?
Okay, that was her. That Micah said a fan for electrical. So energy that produces heat. This is also known as the movement of air molecules, right? If something's cold, does it still have thermal energy? Yes, remember even cold things have heat. Remember our Bill Nye, and he was like, yeah, he said even the freezer had heat. Even cold things have heat. So my heart. Get it? Cold as ice. Wait, what? Oh, you mean dry? That's dry ice. Yeah. Bishop, give me an example of thermal. A thermal lamp. There's actually one right next to you. Ariana at home said body heat. That's what those, like, you ever see those thermoscopes? It's fine. Remember, daylight savings. So the bells are an hour off. So a heat lamp. Carlos? That's on. Yep. That's an the sun is light and radiant too. What is the definition of radiant energy? You should know this from radiation. Radiation. Christian. Very good. So part of the reason I had you guys fill out these notes ahead of time was so that it wasn't so much writing all in one day. But if you're missing things, please take the time to fill them in. So I've got the sun. And then what's another one? Ethan. A light bulb. Ariana. Oh, she said
Microwave.
a microwave. Very good, because it even has that word wave in it. Very good. And then these are our 3 forms of potential energy from earlier. We defined them on the front. So we're just going to kind of briefly do it again. This is energy stored due to position. If something has more height, it has more gravitational potential energy. So this is anything that could fall. We did already write it. Yes? Well, there's a difference between force and energy. Force requires energy, right? If I want to apply a force to something, it requires energy. But gravitational potential energy means that I haven't applied the force yet. It means that the force could possibly be applied. Once I apply the gravity to an object, it's going to turn into what? What kind of energy? As soon as gravity acts on it. Kinetic, it's going to fall, right? So it's that energy is then transferred or transformed. We said chemical energy is fuel. This is energy stored in chemical bonds. We are chemical potential energy. When we die, remember, when we get buried, we feed other living things. It's the circle of life. It's the circle of life. I told you I want to be a tree. Didn't we talk about this? All right. I'm going to be a coffee tree. Burley brand coffee coming to a store near you in about 80 years. And yeah, in a way, and not applying to the religious form of reincarnation, but yes, like, no, it doesn't. That's the circle of life, baby. That's different form of different reincarnation. I'm talking about how we just our bodies literally become fuel or feed, right? So whether you choose to get cremated based off of whatever you believe in, you're still considered chemical potential energy because you're being burned, right? That's fuel. If you're buried, you become chemical potential energy for other living things, decomposers, right? I don't know if you guys have ever heard of a compost. Have you heard of a compost? I have a compost in my backyard. So anytime I like use an egg, I'll put the shell in there or whatever. And worms and bugs will turn the soil and you reuse that to plant other things in. Like I have a garden, I have like cucumbers and carrots and stuff that grow in there. But that stuff becomes nutrition for the new plants to grow. So have you guys ever seen when plants are grown and it ever smelled like manure? Well, that's chemical potential energy. That's fertilizer. It fertilizes soil. It's all of that has nutrition for other living things to grow. So it's kind of a beautiful thing if you think about it. So this would be gasoline, human bodies. Just kidding, but not really. I hope that doesn't happen. Batteries. coal, ethanol. Like, remember we practiced with the ethanol plant with the corn when we burned corn to make gas? No, in the gizmo, y'all. In the gizmo, remember there was the ethanol plant? We taught Bishop. Remember we did the gizmo about energy transfer and how it went from the sun to the corn, and then we burned the corn to make fuel? Yeah, seems like forever ago. And then elastic energy, this is energy stored in objects that are compressed or stretched. Is it all starting to come back to you now, though? Okay. If you better say yes, because number one, you were studying over break like I asked you to. And number two, because you did such a good job with putting forth so much effort before break that now you're like, it's just stuck there. Oh, good. All right, so we said a sling, before we said a slingshot, a rubber band, a spring. Can anybody think of anything else? Ladies, scrunchie. My elastic pants, which have come in full effect lately. Gotta wear the elastic pants now. A slinky. Somebody say a tiger. Tigger would work because he has a springy tail. T-I-double-G-R. All right, how we feel about Tigger from Winnie the Pooh? T-I-double-G-R, that's how you spell Tigger. That's how he says it. We need an education. All right, how we feeling on energy? Yeah? All right. Thanks, Brennan. And hi, Anna. I know Novus is still over there judging him. No ojos? The class pet, because he has no ojos. All right, flipping it. All right, y'all. These two, I'm bringing it back. Heat transfer, because it's something that's on the, it's for sure in the FSA in 2 years. We have 8th grade, you have an FSA. So we have 3 forms of heat transfer. Give me one. Ayana, heat transfer. Remember the brochure that we did? Radiation is heat transfer using rays, right? Electromagnetic rays or waves. Give me another one, Ethan. Conduction, which is direct contact. Which of these two is conduction? The second one, because if 2 things are colliding with one another, that implies direct contact. If you collide with somebody in the hallway, you have touched them, right? Like, oh no, I dropped my books. So this one's conduction. Energy from the sun is transferred through, what is it? There, Ariana's already had it. She said radiation. All right, just to make sure we've got the other one, let's add the other one. Convection is heat transfer through. Yep. What kind of air goes up? Air or water? Is it cold or hot? Hot, right? Like steam. And cold sinks. Very good, y'all. Oops, there we go. Look at us. All right, forces. Yay! Remember, these are on our guided notes. So a force is a push or pull, but a contact force is a or pull that is touching. Very good. Very nice. This is a push or pull that one object applies to another that is touching. That word contact says it all. Examples! What's the one that slows you down? What's the contact force that slows you down called? What is it? Watch your mouth. Yes, it's friction. What is the friction between you and air called? Air resistance. Yeah, I don't understand why y'all call them buggies. A cart, but y'all Floridians call them buggies, and I don't understand that. I don't understand you. So pushing a cart, pulling open a door, gentleman holding a door for a lady. I don't understand you. That's chivalry is not dead, gentlemen. Hold the door for the ladies. I don't hold the door for anybody. Like, what about well, ooh, Ariana said kicking a soccer ball. That's a good one. What about a non-contact force? It's a push or pull.
Without touching.
Without touching. Very good. Look, she into it. And I love it. I am here for it. A push or pull without touching. There's only 3, guys. Give me one, Ariana. Give me one of the examples of a non-contact force. Gravity. Hey. Gravity. So on mine, I drew a picture of the sun and the solar system. Right? That's like it has that gravitational pull. There's, give me another one, Carlos. Magnet. Yeah, I did find the ones that look like this. Remember I told you I had them? They're in my closet. I'll go get one in a second. I think there's one more. What's the other one that we did in class, Mazzy? Static electricity. And we did that. Remember we had the balloon and then the sugar. And then we had remember the hair. Woo. Friction is a contact force. Does it act in the same or the opposite direction?
Opposite direction.
Very good. Acts in the opposite direction. It makes things speed up No, what does it do?
Slow down.
Very good. It makes things slow down. Air resistance. Ooh, ooh. If I have more surface area, what happens to air resistance? If there's more surface area, think about our like skydiving or parachuting. Yeah, if there's more surface area, there's more air resistance. With the parachute, okay, first of all, I don't know why the parachute is attached to his head. It's supposed to be attached to his waist, but I don't know. I don't know why I did that. Yeah, I don't know why I did that. But this is, air resistance is a frictional force between air and objects moving through it. That's fine. All right, we're gonna do these next ones quickly. How does the force of gravity on Earth compare to the force of gravity on the moon? Which one has more gravity? Earth. Why does Earth have more gravity? Oh, raising your hand. Earth has more gravity because, Brennan? Think about our demonstrations that we did in class. Why is it so zoomed? You can phone a friend. Yep, because it has more mass. More mass, more force. This is a test question too. More mass, more force. If you missed something, remember you can find it on my YouTube channel or my website. Looking at this picture right here, are these balanced or unbalanced? Unbalanced. Which side is bigger? The left side. What's my net force? Equals negative what? And it is decelerating. Or you could say that it is moving. Huh? It's going to be moving backwards. All right, what about these ones? I have friction, Ariana, friction, and then the engine.
What'd you say?
What is this, balanced or unbalanced?
Balanced.
Very good, because they are equal. So my net force is? Very good, she said 0. What's the motion then? What's the motion then? Mazzy? Resting or constant velocity? Constant velocity means same speed and direction. Very good. So an object with balanced force is resting or constant velocity. Yes. Or no, because if friction was pulling it backwards, it could have stopped it. Like they could have applied the brake. Does that make sense? All right. Last but not least, we're going to do Newton's laws of motion. There are questions that ask you on the test to identify which specific law of motion we're talking about. For example, one is on your do now. If you look at the second question, that's a test question. The second question on your do now asks you specifically about one of the laws of motion. The first law. So our first law, our second law, and our third law. This comes from the foldable. An object at, just call it out, rest, stays at
Rest.
unless acted on by an outside
Force.
Very good. An object in
Motion.
very good, stays in
Motion.
unless acted on by an outside.
Force.
Somebody give me an example. All right, wait, I'm getting a lot at one time. All right, we said driving, right? So your car, you're driving. Oops, why did I do, I don't know what's happening. And if the car is stopped, the car stops, but you still fly forward, right? So flying forward when you don't wear your seatbelt. When it happened, where you're like, oh my gosh, mom, guess what? This is Newton's first law of motion. Ariana has another one. Give me another example, Ariana.
Kicking a soccer ball and a goalie stops it.
Very good. So when you kick it, the ball's going to stay at rest, and then you apply the force to kick the ball, and then a force for air resistance in addition to the force of a human body is going to make the ball stop. Very good. The next one, to move a mass, you need a. So if I want to move something twice as heavy, I need
Two
very
people.
good. So exactly, if I want to move two people, I need twice the force. So moving twice the mass requires twice the force. If I want something to speed up, what do I need? Well, if I want something to speed up, what do I need to do? I could change two things. What could I do? Yep. If I want something to accelerate, I can either do less mass or more force. Oh, this is my favorite one because it applies to your test. If you study more, you get a better grade because for every action, there's an equal and opposite
Reaction.
Yeah, girl. This is why This is why if you guys let a balloon go, the air comes out this way, but the balloon flies that way. Have you ever noticed? If I let a balloon go, the balloon goes this way, but the air goes this way. So the action is the air, and the reaction is the balloon moving. If you think about it, a plane, the thrusters or the end, you know what I mean? The thrusters, like the fans, they push backwards, the plane moves forward. Or again, what are the swamp boats? The fan boats, the swamp boats. The fan pushes backwards. You studying for your test is the action. So study is your action, and your reaction is A+. At this point, you have everything you need to be successful. We are supportive, hardworking, accountable, respectful, kind. That makes us successful. Have a great day, Sharks. It is a choice.